Yesterday I did something kind of silly. I decremented 2 countdowns and then I checked via the winning method if any of the 10 countdowns reached 0. But since we just decremented the countdowns ourselves, we could just check in place if we just now reached 0 here. So I could say if minus minus rows equals 0 or minus minus colts equals 0, then I want to set the winning number. Okay, and here it's important to use the prefix increment. So the new value should be 0 for both versions here. And I use the single pipe because even though when the first condition is true, I still want to decrement the second counter, just so I don't get confused when I debug the program later and I wonder why is just one of those countdowns decreased. Okay, now if we initialize the winning number to an impossible number like -1, for example, then the winning condition is trivial. Then we can just say we are winning when the winning number is not equal to -1. Right? That should still work. Here are the old results, and we get the same results. Okay, so I think this is significantly simpler. Okay, but then on to the next problem again. So here we have a list of lines. So the first line goes from 0, 9 to 5, 9. Those are XY coordinates. And the demo lines are in a constraint grid of size 10 by 10. So for example, the line 0, 9 would start here and end at 5, 9. That would be 1, 2, 3, 4, 5. That would be here, this line. But another line overlaps this line. That's why a 2 is here, because 2 lines are in this space. Where would that line be? Here, 0, 9 to 2, 9. That would be the overlap here. Okay, so the ultimate goal is to calculate how many places have at least 2 lines going through them, but I thought for today it would be enough to just draw these diagrams, basically. The first diagram only for the horizontal and vertical lines, and the second diagram also for the diagonal lines. Apparently that's harder. Okay. Right, so let's import the demo data first, and let's think about how we want to format that. So we could, for example, define a type for points. Let's call it point, and let's say it has an x and a y coordinate. Okay, so we had 1 point, and then we need another point, and we can combine these 2 points into a line. We could say a line has a point A and a point B. Maybe let's just make it an array. We have const line, let's say demo lines array equals, and then we move the stuff into the array braces. Okay, that would be our demo lines. Let's just quickly make sure that it still compiles, just to be safe. Okay, it still compiles. Okay, now for this grid, we could simply use a 10 by 10 int array. Let's call it grid 10 by 10. And each time you have 2-dimensional arrays, you have to think about what is the y coordinate, what is the x coordinate. So let's say the first one is y and the second one is x, just because that's a convention that I'm used to. And now these local arrays of primitive types aren't initialized by default, but I think I can simply, does this work? Depends on which version of C or C++ you use. The empty brace seems to work. I think that will zero initialize all the elements. If you don't do that, you get random garbage. Okay, cool. So how would we now basically paint a line on the grid? How would we do that? Let's see. Let's take one of those lines. Let's say line n equals demo lines of 0. So we have it at hand, and then we have n point A, point x and y, and we have n point B, point x or y. That's the data that we can work with. So basically now we need a for loop that iterates from this point to this point, basically. Let's see, how would we do that? Yeah, so maybe we could say something like for point P equals n point A, P not equal to n point B, and then, yeah, how would we now change it? Do we need to increment it in X? Do we need to decrement it in Y? Could be anything. So maybe it would be useful to have a vector that points in the direction from A to B. The vector would also have X and Y as coordinates, but I think it would be more type safe to have a distinct type for that. So let's say struct vect, so we don't confuse it with a vector from C++ by calling it differently. It also has, maybe let's call it dx and dy. Maybe that's a bit more understandable, that it denotes a delta between points. So basically I want basically to have a difference between 2 points. How would I do that? So ideally I would want to say, a vector v equals n point B minus n point A. Okay. And then I would like to normalize that vector somehow like this. Or maybe let's do it as a member function. Normalize. Okay. None of that stuff exists yet. I'm just dreaming here. And then we could say P plus equals V. Okay. Something like this. And of course, now we should get lots of compiler errors. Let's see. Yeah, so we can't subtract points from each other. At least not yet, but we can implement that. So in C++, we can say operator minus takes a point, I don't know, P and a point Q, and then it returns a vector. What vector is that? That would be, with nice initialization syntax, that would be Q point X minus P point X, and then Q point Y minus P point Y. That should be it, right? Yeah, I think so. Yeah, I think I got that right. Okay, so that's the first error. Then the next one was the normalize. So let's do that here in the vect. Let's just make a method, normalize. Okay. How do we do that? So basically, if x is not 0 and it is a positive value, it should become 1. If it is a negative value, it should become -1. So basically, we want to say something like dx is the sine of dx and dy is the sine of dy. So yeah, for diagonals, that's not really normalization, right? The total length is not 1, but the components are 1. I'm not sure if a function like sine already exists in the standard library, but it's quite easy to write it yourself. So sine of some value I, we can simply say if I is smaller than 0, then we return -1. If I is bigger than 0, then we return +1. Otherwise, we return 0. Okay. So that should then work. Let's see. Okay. Oh, too many colons and not enough question marks. That's this. Okay, no match for operator not equals for point and point. So we can't compare points yet with operator not equal, but of course we can implement that. Where's our point? Here. So we can say operator not equal of point P and point Q. Okay, and it returns a bool, not a boolean. So when are they not equal? When px is not equal to qx or py is not equal to qy. Right? So if either of the components differ, then the whole point differs. Okay, right, so does that now work? Okay. Operator plus equals doesn't exist yet on point and vect. Okay. So I think, does plus plus equal have to be a member function? I think so. That's too bad because the vec doesn't exist yet. But we can trivially move it up. Let me move it up here. Okay. And then we can say operator plus equal of vect v. And then we can say x plus equals vx and y plus equals vy. Okay. That should hopefully work. Let's see. Okay, now the sign, we have to move the sign up as well. So that's one of the unfortunate properties of C++, that the compiler works from top to bottom in most cases. Okay, what else do we have? Oh, right, it should be dx and dy. Oh, I love these modern compiler error messages. They are just great. Dx and dy. Okay, and now apparently we have an infinite loop or something. Let's see. Oh no, I mixed this around. This should be P, and this should be Q, this should be P, this should be Q. What do we want to do instead? We want to basically render the point onto the grid, right? So grid at P.y and P.x should be incremented. Okay. Yeah, and I think then we can do that for all the lines basically, right? Okay, so we can say for const line in demo lines, and then we have this code, and then that would be line instead of n. That's a better name anyway. N sounds like a count of something, a number of something. Okay, so then we should have rendered all the lines, and then we can simply print the grid to the terminal. Standard for loop that we all love to write, and then we print grid of yx. That will give us a 0 instead of a dot, but we can fix that later. And then after one line, we have to print a line break. Okay, let's see if that does something sensible. Okay, so there are some 3s in there already, maybe because we already draw the diagonals. Okay, maybe to compare it better, let's say if what we try to print is 0, then we want to print a dot. Otherwise, we want to print it. Does that make sense? I hope so. Oh boy. So without further looking at it, that's probably an operator precedence thing. So let me simply parenthesize the comparison, and let's see if that fixes it. Yeah, okay. Oh, still we get zeros. Why is that the case? Okay. Let me know in the comment section below what I did wrong here and how I would write it in a single line. Maybe it's not even possible, I don't know. Okay. Yeah, so that looks a bit better. Now we want to solve part 1 first, of course. So we only want to print the diagonals. So only if the line is a, how do we call it? Let's say diagonal, like this. Okay. And of course, this function doesn't exist yet, so we have to write it. So how do we determine if a line is a diagonal? Well, the horizontal lines have the y positions in common, and the vertical lines have the x position in common. So we could simply check if both of them are different, right? So diagonal is a const function. I don't know if I marked everything const that I could have before. So if a dot x is not equal to b dot x and a dot y is not equal to b dot y, then it should be a diagonal or a completely weird, erroneous line. Yeah, okay. Yeah, let's see how that looks. Oh, what did I do wrong? Oh, what? It doesn't belong in the paint algorithm. It belongs in the render algorithm. So that would be here. Okay, so that's not correct as far as I can see. Now we only have the diagonals. We want not the diagonals, if not line diagonal. And maybe that's a good time to say I really don't like this operator. The not is so important and you almost don't see it. So I would prefer to write not. And does it even, maybe it works, or I have to enable some flag. Yeah, many C++ programmers don't know this, but you can use not and or, but it's almost nobody uses it. So most people say not with an exclamation mark. Okay, so that looks at least similar. Let me move the terminal to the right. Now if I scroll down a bit so we can compare it better. Yeah, so here this line is too short. Here we have 2 ones. Here we only have 1. Here this cell is missing on the right. I think this is also too short, so we're missing 1 point. And that makes sense because here we say as soon as we reach the endpoint, we stop. So we don't enter the for loop and paint that point anymore. We stop 1 too early, basically. Yeah. So we really need a different endpoint that is one beyond the actual end, basically, right? How would we do that? So we could say point end equals line B, and then end plus equals V, and then we compare with the end. Yeah, I think that makes more sense. So only after we have reached the actual end, right? After we have stepped over the actual end, then we want to terminate. Let's see what then happens. Yeah, so now here we have both ones. Now this cell is active. Now here we have the 6th one. So this is better. And this is the exact reason why begin and end in the C++ standard library are inclusive and exclusive. So then these kind of loops that you intuitively want to write work. You don't stop too soon. You don't stop at the last element, before the last element, but only after the last element. I think that's good to see. Okay, yeah, I think that's fine, like it is. Okay, and then if we remove this check for the diagonals, then we should get the second diagram, which we can see here. Let me quickly check. Yeah, that looks good, that looks good, this looks good. Yeah, this all looks good. Okay, and then we would count how many of those numbers are more than 1. Anything else interesting going on? Yeah, so for the sign function, some people will notice that this is unnecessarily complex. So if this condition is true, I want to return a truthy value, else I want to return a falsy value. I can just get rid of this and just say, you know, this will be true or false depending on the I greater than 0 condition that does the correct thing. And another possibility would be to say I greater than 0 minus I less than 0, but I think this is a bit too cute, but it would also work. Okay, then you can see that structs, just as classes, can have methods. So the only difference between structs and classes in C++ is the default visibility. So here I have an implicit public, basically, and for classes we would have an implicit private. That's the only difference between structs and classes. Plus inheritance works a bit differently by default. Okay, yeah, then the operator plus class usually doesn't return void. Usually it returns a reference to itself. So you can write cute stuff like, you know, A equals plus equal B, and then use that further in an expression, pass it to a function or assign it to another variable. And if you want this stuff to work, then you return a reference to yourself. Okay, then here we have the comparison operator. You can also write comparison operators for equals and less than, greater than, less than equal, greater than equal. And modern C++ has something called the spaceship operator. Then you only have to implement this one guy, and all the other 6 will be generated from it, basically. That's also worth knowing, but it's only since C++ 20, I think. Okay, yeah, this is the only const function that I could have made const. Then here we have our array, then we have another operator. Yeah, and every time you write these operators that only read from the parameters, you can think, should I pass it by value or should I pass it by const reference? By value means copying, so we copy 2 ints, which is probably 8 bytes, and a reference is also 8 bytes, plus you pay the point of indirection, the cost of indirection. So I think for these small types, it's perfectly fine to pass them by value and copy them.